We all understand that solar is promising. We know that there is a lot of solar energy available. The problem is that it's too expensive.
One thing that we're very proud of about 1366 is that we have very strong competence in developing a manufacturing process. So the way the industry standard multi-crystalline wafers are made, it's a very laborious process. You end up purifying twice as much material as you use because half of it ends up as dust. Lots of steps, lots of cost, and very high capital expenditure requirement.
We had one particular process that was very disruptive but also more risky, and that was a whole new wafer manufacturing technique. It was largely an unfunded effort until we were funded by ARPA-E. In the spring of 2009 that we sent in that proposal, and by the end of 2009 we were under contract.
It allowed us to rapidly hire and also gave us a pool of resources to build equipment. A good analogy is how glass used to be made. If you look at windows in structures from the 19th century, you'll see that the windows are very small and they're often not very flat. People got better at making them flat, but the way they did that was by taking these pieces of glass that they had cast and grinding and polishing both sides. So incredibly expensive, and that's why windows remain small. Then Pilkington invented the float glass process, where molten glass is floated on a bed of molten tin. And this is a continuous process which creates the glass to the finished size and surface finish. And that's how essentially all glass is made today. As a result, not only is the quality higher, but also you can afford to make large pieces of glass, and that's completely changed architecture. What we do is we take the same purified starting material, we melt it in a crucible, and we form a wafer at the surface of the melt. So it's a very fast process, and most importantly, there's no sawing required.
As a country, we need to be energy independent. The purchases that we make as an economy to meet our energy needs are more than half of our trade deficits. 40% of the world's pure silicon, for example, is produced right here in the US. Most of that is exported, and that represents an export of about $1.7 billion. Turn all that pure silicon into wafers, and even allowing for a price decline, you turn that into a $7 billion export. That would mean an extra $5.3 billion of money into the economy. That would represent roughly 30,000 jobs. By working on that, we make a future where we are energy independent, and we produce all the energy that we need right here in the US.
Getting the ARPA-E program was very important to us. That proved to be essential to our recent success in raising private investment of over $30 million, because we had advanced direct wafer to the point where potential investors could see what the future might hold. The power from the sun is about 10,000 times the average power consumption of all of mankind.
In the long run, it's the only viable way that we have to fuel our society. The question is, how quickly will we get there? And of course, at our venture, we are dedicating ourselves to make that sooner rather than later.